So what we're going to see is an example of a struct. So as I mentioned, a struct is a composite data type. It's a way that you can take a bunch of variables that may be related to something and store them in one common structure. So I gave the analogy of files being stored in a folder earlier. So in terms of a struct, where would you actually create a struct? Well, it turns out you would create a struct before your main, so outside of your function, because you're going to want to use the struct possibly in multiple things. So it's like defining a type. So we're gonna create a composite structure for a person, which I think was the example that we were given, or that was suggested earlier when I introduced this. So struct person. So the way this works is that you use the word keyword struct, the name of it, and you put an open bracket, open curly brace closed, followed by a semicolon. And inside here, this is where you actually put the data that's contained in the struct. Now, if we're doing a person, we're probably going to use names. So I'm also going to go up and I'm going to include which library? String, right. So we're going to probably use a string here. So what would be some good examples of data we might want to include here? String, say first name. Now what did we decide on what naming convention? What do you want to use today?
I use camel case.
Okay, we can do it this way. That's fine. As I said before, I'm not going to be too picky about what the naming convention you use is, except to make sure that you're consistent within your programs.
What do you normally use, the underscore?
To be honest, when I do C++, I do tend to use the underscore more. When I use Java, I tend to use what I'm using now. Okay, so string, first name, last name. Anything else we might want to int age, or should we use a float for age so we can?
Unless you want to do months.
What? Like, you know, somebody is like 36.2 or 18.999, meaning their birthday's tomorrow. I don't know. We'll just do an int then. Anything else we want to keep?
Gender.
What? Occupation, sure. How about whether or not they're employed? Why don't we do Boolean? Is employed. And what about a bool is student? Right? Yeah? Gender? What do we want to use for gender then? Do we want to
0 and 1.
0, 1? Boolean, I see. So gender is an interesting one. Boolean is the problem though is which one is true, which one's false, right? And to be honest, what I would suggest for gender is either a character or a string. It doesn't really matter. What? We can use it. It doesn't really matter to me, but you could do that. I'm not going to put in gender right now, only because I think we've got enough items to do here. So we've got 5 different types of data that are stored in this. So now what we do is let's actually see this. So since we've already learned pointers in the class, I could do this as a dynamic variable, but first I'll just do it as an ordinary variable. And an ordinary variable means what? What's an ordinary variable? Or automatic variable? An ordinary variable is one that isn't created dynamically, so we don't create it with new, we don't have a pointer for it, we don't delete it when we want. It's created at the start of the function and deleted at the end, and it's not stored in the heap, it's just stored in standard memory. So in our case, let's actually do that. So we're just like we'd create an int x or whatever, we can go we now, because we call this a person, we can just declare now a person p. Right? And in this case now, our person, just like we declared variables of type int, string, float, or whatever, this struct, we can actually use this as just a regular type and declare it. Question?
When we, like, you know how we're declaring, like, struct person, we're declaring all our variables, does that count as a constructor, or do we have to build the constructor for that person?
There is no constructor. A struct only contains data. It is a composite type. A constructor is a function that's often used to initialize values of the variables and that kind of thing. Structs are just simply containers of data. Okay? We'll learn it. We'll look into that in a little bit. Yeah.
Is there any like structs in Java? Because I don't really remember seeing that.
Yes. So typically the way it would be if you have a class, say called person, you'd have a function called person, so you could go new person.
Yeah.
That's a constructor. The constructor was the function with this.
Is it the same as a struct? Like, you know how
No.
C++ has a struct?
Java has classes. C++ also has classes. We're going to get to that after. Classes are different than structs. So structs are just composite data types, and they actually aren't even related to object orientation. This is just simply a type of data. And I just want to show you this because this is something that you can do in C as well. And I want to get you a sense about how programming moved from just having sort of, your different variables, independent data variables, to the idea of using structs to organize them, and then to using classes to not only capture composite data, but also functionality as well. So we'll get there, but for now we're just dealing with a struct. So if we create a new person P, well, it turns out the way we actually go about accessing and setting things like the first name and so on is we would actually go P dot, and we use the dot operator here to access all the data that's inside. So P dot first name equals, let's do cookie. I normally, in the past, have used students' names in the class, but because I'm putting them on YouTube, I don't want to use students' personal information. So we'll just, we'll take the Cookie Monster, right? We should have put hair color blue. But anyway, we can.
It's not too late.
It's okay. So P.age. How old is the Cookie Monster?
Oh, it's so Google.
42. Okay. Is he employed?
No.
Isn't he a quality tester for
For cookies?
one of the cookie
Christie?
factories, Christie's or something? No. So we're gonna say false. He's an unemployed monster, eater of cookies.
P dot is employed?
Oh yes, that's right. Sorry, I just did the variable. So this is, if is employed was just a regular variable, we go is employed. So it's P dot is employed, and we want to go P dot, is he a student? Actually, he's sort of employed by Sesame Street, isn't he? So I'm going to actually put that he may get a small stipend from Sesame Street, and that. So right. So we'll say he's employed. Let's give him some benefit, right? So that's cool. So we now know that. So we could do things now like this. We can say P dot first name. Oh, I did. You're right. Thank you for pointing that out. P dot first name, P dot last name. We'd probably want to put a space between these. What do we want to say? What did you ask?
Oh no, like when I go to do the autocomplete it, just puts in some.
Oh, some of the autocomplete is not what you'd expect.
Yeah.
Yeah. Year old. Yeah, we could do person here. We could just do that for now. I'm not using the is employed as student at this point, right? Well, let's just try this out and see. I don't need an end line, but so here's the thing though, is an end line here might actually be good because otherwise it'll end up in the same line as my as the command prompt. So I am gonna let's just put one in just to have that there. It's not required though. So now that I have this, I can go G++ struct, Let's see, does it compile? It does, cool. Now, I just want to show you something though. You can't access, just because those variables are in the in that composite type, you can't use them like this without the p dot in front of them, right? They don't exist. They're not variables. They only exist as being part of a person variable. You can't use them on their own. So if you did something like is employed or first name right here and you try to compile, it's going to tell you first name is an unknown identifier. It doesn't recognize the name unless you say p dot, because it first says, okay, I've got a variable of person p, and inside of the person p there is a first name. Okay, so I have to go p dot first name. And let's just compile this and run it really quick just to see what happens. And it turns out Cookie Monster is a 42-year-old person. Yeah.
How come you have to put the semicolon after that parentheses and struct person?
Oh, right here,
Yeah.
as opposed to not.
Well, like, yeah, you think you wouldn't, right? Because it's in that curly.
So this is actually, it is the syntax. I'd have to be honest, I'd have to go back and check what it is. But if you think about it, it is sort of like, this is the way I always think of it. You have a struct person, is what you're creating. And this is where you, inside of that, you say these are the data types.
Okay.
It's sort of similar to, if you think about it, a good example, there are other times where you use the curly braces and still use a semicolon, right? For example, when you, if you declare an array and initialize it on the same line, you can use the curly braces for the values and then still use a semicolon. So just because there's open and closed and curly brace doesn't mean that there won't be a semicolon. Yeah.
Is there like, does it matter where the semicolon's supposed to be? Like, can it be like where the struct person is?
No, it would be this way.
Is it-
Yeah, because the semicolons are used in C++ as a way to indicate the end of a statement. Okay? So you can actually, this is just an aside, but you can actually do this and it will work, should compile perfectly and work perfectly. You can put in extra semicolons because this is basically just saying there's an end of an empty statement. This says the end of a declaration statement where you declare a person. This is the end of an assignment statement where you assign the value cookie to the person, the person P's first name. So semicolons are actually a separator that are used to separate different statements in your program. And the compiler uses them to know when one statement stops and another statement begins. So that just shows us a little bit about how to actually do an ordinary variable version. Now I'm going to also do, just to keep things interesting, I'm going to also do it as a dynamic variable as well. Because we've been doing a lot with pointers, so I want to make sure you understand how we could use a pointer here to point to this data type. So unlike an int or something, when we create the pointer, when we set the pointer to equal a new person, what we want to do now is we're going to want, that pointer is going to want to set aside enough memory to store all of the data for a person. Okay, not just 32 bits for an int or whatever. It's going to set aside enough to store our 2 strings, our 2 bools, and our int. So if we want to do this, we could actually, now I'm not going to create a new type def called person pointer or anything like that. I'm just going to create a person. Let's call it star p2. Now I could put that on the next line, this equals new person, but I'm just going to do it all on one line. So I declare that I have a new pointer p2, and I immediately on the same line say that it's going to be used to point to a new person, a new dynamic variable. So it's going to set aside memory in the heap for this person variable. So if I wanted to do this now, I'd have to go star p2 dot first name equals big, right? Now it turns out this notation here using the star and the dot and the brackets, that's not really ideal, is it? That's kind of messy. So it turns out when you're dealing with dynamic variables and you want to access say, for example, you have a struct with different declared variables inside of it. There's actually a notation that's equivalent to using the brackets and the star with the dot that is actually just much more convenient to use, which is instead you can go P2 and an arrow. What? Is that okay?
Yeah, using an arrow.
So I'll just put, this could be, or let me just put this is same as P2 arrow first name equals big. Just so that everybody understands, these are the same things. It's just, it's the arrow is considered a bit more convenient, easy notation. So how old is Big Bird? Well, I think he's probably what, 86? Although birds, I don't know how long do birds live. Probably less. 86 in bird years. Let's say 86 in bird years.
Bird years.
What?
86 in bird years?
Yeah. I'm just kidding. I have no idea. So, and then, is he employed? Well, yeah, it turns out he's also employed. And I don't think he's a student either, so.
You're close. Apparently the puppeteer is 81.
There you go.
Yeah.
Should I change to 81 then?
Yeah.
Same age as the puppeteer?
Yeah, P2 81 doesn't really work.
Oh, yeah, that doesn't really work at all. Okay. Age equals 81, yeah. Okay, cool. Awesome, right? You got Big Bird, he exists. And I'm not going to actually display this one out with cout statements for now. You could do the exact same thing as this. I guess we could do it. If you just took this and replaced the P dot with P2 arrows, you would be able to display out his name. So we could say, we could do here, let's just do if P2 is employed, we'll display out a message that says P2 first name followed by space followed by P2 last name put another space, has a job. Sound good? Else, what are we going to say? I'll just cut and paste this here. Else, I'll just put needs a job. No, is currently between employment opportunities. What? There's nothing wrong with that. It's currently exploring employment opportunities, maybe I should have said. Okay, so if we now save this, let's actually see if our, oh wait, what do we need to do with a dynamic variable when we're done with it? Right, and because this is a composite type, unlike with an array where we have to do some sort of funky like square brackets or that kind of thing, we don't have to do anything special for deleting a composite type or a struct. So we just go delete P2 and we're done. Okay, so let's give this a try. Compiled, run. Hey, Cookie Monster is a 42-year-old person. Big Bird has a job. Go Big Bird. Yes.
Instead of using the if else, why not use the dynamic operator?
What?
Why not use like the conditional operator instead of if and else?
So what would you do instead?
You can have cout, arrow, then put in a bracket P2 arrow is employed, and then question mark has a job.
Yeah, you can do that, and I haven't. So here's the thing. I'm showing you, in some cases, I'm showing you different notations. Like I showed you that if we have a dynamic variable for a struct, we can use the brackets with the star, the name, bracket, dot, or we can use the name, arrow. One of the things, this is a first year programming course, so one of the things I don't want to do is I don't want to, especially for students who have not programmed before, I don't want to overload with all the different variations. One of the nice things about some of these languages like C++ and that is they've been around for a long time, and there are different ways of actually doing the same thing. There are different notations that some people prefer versus others. In this case, I haven't been doing that in anything with couts or whatnot, simply because I don't want to introduce another type of syntax at this point. So I'm just sticking with a certain set of syntax that we've been learning. That isn't to say that's the only approach. So if there's something like that where you know it and you know there's an alternative, that's actually a good example of something you can actually do is use the other example or try that with the, in your own time or even when you're programming along with me. So I'm not discouraging you from using it, but I'm not necessarily always going to say, hey, here's all the other variations of how we could do this. But thanks for bringing that up.
So maybe small.
Yeah, you could. So there are disadvantages and advantages. It makes it smaller, but if you have a very long cout statement, it also makes it harder to read, right? And there's a trade-off there, right? Size of the code. Some people want to have really compact code that's the smallest possible, and other people, it's also about whether or not the code is readable because it has to be maintained later, possibly by somebody else. So it is a trade-off. So here's one of the things I find really annoying about our example. Setting all these variables, like having every time we create a new person, we have to have like 6 lines here. So what I'd like to do is I'm going to actually create a function here, which is going to return a pointer to a person, and I'm going to call it create person. And it's going to take in a string f, a string l. You see where I'm going with this? An int age, a bool e for employed, and a bool s for student. Sound good? Any questions about that? So what's this called? This is a function what?
Constructor or initial?
Declaration?
Oh yeah.
Right, so we're declaring the function here, and then where do we put the definition? We put the definition after. So down here, we're going to create a function here that does this, and what are we going to do inside of this? I'm going to use a pointer right here to create a new person, just like I did up there with the Big Bird example. I'm going to make this person's first name equal what? The parameter f. I'm going to make the last name equal the parameter l. I'm going to make the age equal what? The parameter a. I'm going to make the is employed equal what? E. And I'm going to make the is student equal s. And then what I'm going to do is I'm going to return this pointer. Now, remind me, why would this is because this is a dynamic variable. I created a new dynamic variable called temp, where I'm setting up a new person, variable, dynamic variable. Why? So when I return the temp, why don't I have a delete in this function again? Can someone tell me?
Because it finishes at the return, so you can't really.
Yeah, because I'm returning the pointer, I can't delete it after, because it's already returned. Now, the good news is that because the pointer, the address of this dynamic variable is going to be returned, we're still going to use it. So whatever variable we return it to, once we delete that variable, it'll get cleared up. And our original pointer, temp, will no longer point to that variable. It's actually going to get deleted, and that memory is going to get freed up when the functions end. So just to show you, let's look at an example here. Let's have a person star p3. And instead of saying this is equals a new person, I'm going to say equals create person. And I'm going to pass in the information here. So I'm going to, what's another one here? Does Ernie have a last name?
Google it.
What? Bert and Ernie, they're not one person. Does Ernie have a last name? Can someone Google this? This is important. Ernie, last name unknown. What's Ernie's age? 36.
Nathan, Ernie, Sir Ernie. I don't know. You can give him a surname.
No, I'll just put LNU for last name unknown.
Should have did Oscar the Grouch.
Is the his middle name?
I think so.
Okay. So 36, he's employed, true, and yeah, maybe he is a student too. I think he takes some night classes. Right? He likes to sing in the tub. Maybe he takes some night like music classes or something. Okay, so then we just created our person, right? Ernie, last name unknown, and so on. And we can still do things like oops. So we can still print out messages and stuff. Now, because this is a dynamic variable, when we're done, what do we need to do with this with this person? Yeah. Delete P3. And this will free up the memory that when we create it, because we use the create person function here. So we create that temp variable and set aside some memory when we set up this new Ernie variable. And we pass the reference to that back. So P3 points to that memory we use. So when we delete P3, it actually frees up the memory that we set up over here. So let's give this a try and see. Oh, we have a problem. What did we do wrong?
The at line or the end line.
There's no
Yeah,
string.
there we go. That's a silly one. Okay, let's see. Does it work now? Yeah, it works fine. Perfect. And it says Cookie Monster is a 42-year-old person, which was our example of an ordinary or automatic variable of a struct. Big Bird has a job, which is cool. And we saw how to, with a dynamic variable, we could also have a function which we use to create this. So we saw that Ernie is 36 years old, which was from our, which we used for the create person. Any questions about this? So things you should remember from this example is you should remember if you want to have a composite data type, anything like where you have a bunch of ints or strings that are related to each other and you want to group them in some way, you can use a struct to create a composite structure. So you should remember this from this example. You should also remember that these structs, just like these composite structure variables or types, just like any primitive type like int or whatever or any other type, we can actually declare them as ordinary or automatic variables, just like this. And when we do that, we use the dot operator to access the data types inside. Or we can also create them or declare them as dynamic variables. And if we want to do that, we can use this notation here where we use the star P2 dot. But we can also have this convenient notation where we can use P2 arrow as an alternative to this. And we also saw that we could actually use a function here to kind of set up or initialize one of these structs. Now, here's the downside of this. This function create person really is very related to the struct, isn't it? Right? However, it's its own function, so it's separated. So the struct contains all the data, and the function for creating a person of that type is actually outside of the struct. So the struct only contains the data. The functionality or the function for actually using the data is still separate from it. So what we're going to see next is we're going to actually see how we can use classes and object orientation to not only encapsulate or contain the data, the variables, but also the functions. Things like this create person function can all be within a class as opposed to being some inside a struct and some functionality outside. So that's where we're going to next.